All right, so we're going to solve this inequality. The temptation is to cross multiply, but of course you cannot cross multiply. The reason is you don't know if the 3x plus 1 or the x minus 1 is a positive value or a negative value. And with an inequality, if you're multiplying by a negative, you would have to switch the sign. So the best we can do, and I'm just going to go over here, is subtract. So I'm going to have x over x minus 1 minus 2 over 3x plus 1 is greater than or equal to 0. And the rest of this problem up to a certain point is just going to be on trying to simplify this. So we're going to go ahead and get a common denominator, which will consist of x minus 1 times 3x plus 1. That means I would have to multiply my x by 3x plus 1, the minus 2 by x minus 1. And continuing our simplifying, we're going to distribute the x. So we have 3x squared plus x minus 2x plus 2 over x minus 1 times 3x plus 1. Simplifying further, we have 3x squared minus x plus 2 over x minus 1 times 3x plus 1 greater than or equal to 0. All right, now we've done simplifying, and our next job is to find what we call the zeros. And we're really only interested in real zeros. So we're going to take the numerator and set it equal to 0. Now that numerator doesn't really factor, so we'll use the quadratic formula. So 1 plus or minus 1 squared minus 4 times 3 times 2 over 2 times 3, which is 6. Now you'll notice that what I get is x equals 1 plus or minus the square root of negative 23. Now that's not a real number, so there are no real zeros. All this really means is that when I draw my number line, I do not plot those numbers on the number line. All right, I'm going to flip the page. So we're going to take our problem, which was 3x squared minus x plus 2 over x minus 1 times 3x plus 1 greater than or equal to 0. No real zeros, so our next job is figure out when it's undefined, because we do not want to include values where the rational expression would be undefined. So we're going to essentially take our denominator, x minus 1 times 3x plus 1, set it equal to 0. And we get two values, 1 and negative 1/3. So here's where we draw our number line. We're going to plot our numbers. Negative 1/3 would go first, followed by 1. And now we're essentially going to test our problem out. There are three sections of the number line. Those numbers that are less than negative 1/3, between negative 1/3 and 1, and greater than 1. I find it easier if I separate it. So I'm going to look at 3x squared minus x plus 2. And all I can do is I can pick a number here, let's say negative 1, plug it in and determine if the value is positive or negative. So if I plug in negative 1, this will become 3 plus 1 plus 2. That's positive. Here I'll pick 0. 0 minus 0 plus 2, positive. And if I pick 2, I would have 12 minus 2 plus 2, positive. So the 3x squared minus x plus 2 is always positive. All right, looking at the denominator, we have x minus 1 times 3x plus 1. And we could essentially do the same thing. So pick negative 1, plug it in. That'll give me negative 2 times negative 2. That's a positive result. Put 0 in. That's negative 1 times 1. That's negative. And plugging in 2, we get 1 times 7, and that would be positive. Now we're dividing, so we have a positive divided by a positive here. The result would be positive. We do want numbers greater than or equal to 0, so that part of the number line I am interested in. Between here, we have a positive divided by a negative. That would result in a negative, which is not greater than 0, so we're not interested in that. A positive divided by a positive again is positive. We wanted greater than or equal to 0, so we want that as our solution. Our final answer then would be x is less than negative 1/3, or x is greater than 1.